Okay, here we have the same merry-go-round. Originally we had a child located 1.1 meters from the center, and they were moving with a tangential velocity at this point of 1.5 meters per second. Now, same merry-go-round, somebody else is located 2.2 meters from the center, literally twice as far away. Now, before we begin, let's use a little bit of logic. They're all connected to the same turntable, the same merry-go-round. So the time it takes each person to go around once is identical, right? They're all connected on the same platform. So if the person on the outside has to travel a bigger distance in the same amount of time, it stands to reason that their velocity on the outside would be much larger. So we'd have to calculate that one if we wanted to use the v squared over r formula to find the acceleration at this point. But let's just use our physics intuition and logic to solve this question. We know that our centripetal acceleration, we can either go v squared over r to calculate it, or we can use 4 pi squared r over t squared. Now, if I want to compare the centripetal acceleration at 1.1 meters to that at 2.2 meters. Now, I only know the velocity at the 1.1. I don't know the velocity at the 2.2, so I have to figure that out if I want to use the second equation. Remember, v changes. So if I'm focused on the first equation, sorry, I said second, but the first equation, I need both v and r. Both are variables in this case. The 2.2 is different than the 1.1, and we've just discovered that the velocities are different. However, if I look at the second version of the equation for centripetal acceleration, it depends on 4 pi squared, which is a constant no matter what vantage point you're looking at. Depends on the radius, which is changing. It's going from 1.1 to 2.2, and then divided by the period squared. So all of that first part for both riders on the merry-go-round is constant. So if I use the second one, it's saying that my centripetal acceleration is some constant times r. So in other words, my centripetal acceleration is directly related to the radius. If I double the radius, then I double my centripetal acceleration. AC originally at the 1.1 meter was 2.05 meters per second squared. So now my centripetal acceleration at the 2.2 meter mark will be 4.09 meters per second squared.